Hello YouTube. Today I'm going to try to explain or give you just the simplest basics of how a radio works. Radio waves they're called electromagnetic waves. They're magnetic in nature. So as these waves strike an antenna, being they're magnetic, they generate a small amount of magnetism in the metal antenna that they strike. So a basic radio has an antenna, which I drew there, which is the antenna symbol. And most radios today use, they don't even use an RF amplifier for the first stage. Most radios go right into just a tuned circuit. So we'll say a tuned circuit, we'll just mark that with a T. And it's a variable tuned circuit. Like it changes, as you turn your dial up and down on the radio. The tuning changes from, we'll say we're talking about AM radio. It's about roughly a half a megahertz. 0.5 megahertz, or is it 0.55 to 1.6 megahertz, something like that for regular standard AM transmission, or for the USA. So yeah, after it goes through the tuned circuit, then the signal heads into what's called a mixer. And what the mixer does is it has a local oscillator. I'll just call it LOC. Local oscillator is also variable with this tuning. So these two guys got to more or less be synced. So as this is tuning a certain frequency, that local oscillator has to be close to what this is after as well, so they match. So local oscillator also feeds into the mixer. And what comes out is called the difference frequency. So the difference frequency is actually called the IF, or intermediate frequency. So then that goes through an amp. It gets amplified a couple times to make it stronger. And right after the IF stage of amplification, it goes into what's called a detector. Just put a DET there, detector. Stands for RF detector. Let me move this camera a little better. So yeah, the detector actually strips the radio energy wave off of and what's left is just the audio that's riding on top of the wave, kind of like piggyback. If you watched my last video, you can see what I was talking about with the modulation on the RF generator. Yeah, the audio signal actually rides on top of the RF wave, kind of like a surfer riding the wave of the ocean. The surfer would be the audio, and the ocean would be the RF carrier. That's why they call it a carrier, because it carries the information by being modulated, but you got to remember the modulation is at an audio rate. So once you strip that carrier off, what you're left with is audio or sound. So yeah, then after the RF detector, it just goes through a regular audio amp, audio amplifier, and then to your speaker. And that's basically the simplest way I could explain how a radio works. But now this is only one type of radio. This is an AM radio, or as they call it, amplitude modulation, which means that as the radio station is transmitting a signal, if there's no sound, the carrier is just like a flat line, it's like it doesn't move. But as soon as the radio, as soon as there's sound there, then the carrier changes in height. You know, it goes up, it goes down, it can even go to zero. You know, and that's like I said, that's your audio impressed upon the carrier wave, as they call it. Now, FM is a different animal. I don't want to get into that too much. That's a lot more complicated, and there's even parts of that with stereo that I really do not understand how it really works. But FM radio is frequency modulated, where unlike AM, where the amplitude of the wave keeps changing, FM, the frequency keeps changing by an audio rate. So that gets a lot more complicated. But just basically, this is how AM works. Like I said, antenna, tuned circuit, tuned local oscillator. These two guys are in sync, and a mixer. So if a signal comes in and it hits the mixer with the local oscillator, it keeps changing as well. You get what's called the difference frequency, which is actually called the IF frequency. It's usually about 455 kilohertz. Yeah, 455 kilohertz, KHZ, is what this amplifier is tuned to. Like, it has a very sharp tuning for that frequency. So if anything else comes through the mixer, like higher frequencies, lower frequencies, they will not get past the filtering of this tuned circuit, the IF amp. The IF amp is a very narrow bandwidth. So, like I said, yeah, other frequencies are going to mix and be present, but the tuning of the IF amp will not allow these other frequencies to pass. It will only pass that one frequency that matches the difference between the local oscillator and the incoming signal. So all other frequencies will be technically rejected. I mean, it's a very complicated stage to try to explain to you, but that's basically the basics of it, you know, how it works. You know, it's all about isolating a certain frequency so you don't have, I guess we would call it crosstalk, or other stations bleeding in on other stations. Yeah, it forms like a very narrow band tuning, so nothing else can get through. That's close. So it gives you more selectivity, you know, as far as to what you're trying to receive. As I said, that's important, because you don't want to turn your radio on and be getting 2-3 stations at one time. So they run it, like I said, they run it through the mixer, and then the IF amp is really what has that very narrow bandwidth of what's allowed to pass through there. So I hope that helped as far as you understanding the basic of how a radio works. An AM radio, anyway. And shortwave, too. The only difference between AM and shortwave is shortwave is a lot higher in frequency. I'm not sure where shortwave starts. All of Europe and that uses it. Like, I think the United States is the only one who uses AM. Like I said, we got about 0.55 megahertz to about 1.5 or 1.7, whatever the hell it goes up to. I don't know the exact specs, but I'm just giving you the rough. You know, like so basically half megahertz to 1.5 megahertz is AM band that the US only. The US is probably the one who uses. Europe and that uses shortwave. Shortwave starts right above us, probably at 1.7 megahertz, and all the way up to, I don't know if it's 16 or 17 megahertz, somewhere in there. But it's still amplitude modulation as far as how, you know, just like our radio is. It works the same way. The only difference is their frequencies are different. But, yeah, it's all the same as far as the operation and how you, you know, tune in and select and amplify and all that bullshit. You know what I mean? So Thanks for watching. Thanks for coming along. Please subscribe. We'll see you all again later. Bye-bye.